We have another example on the board. Using addition-subtraction method, we have learned that we're supposed to eliminate one of the variables in order to solve the system of equations. Let's take a look what we have in this example. We have to look first at the coefficients which are next to x and next to y. Okay, this time I'm going to use a little bit shorter way to solve this kind of problem. We want to eliminate one of the variables. Please notice that the second equation has coefficients which are divisible by 2. But in order to eliminate one of the variables, we said we're supposed to make sure that the signs are going to be different. The coefficient is supposed to be the same, but the sign is supposed to be different. So if I'm going to divide the second equation by -2, let's take a look what will happen. I'm going to copy down first equation, and I have 2x minus y is equal 4, and 4 divided by -2 is going to give me -2x. -2 divided by -2 gives me +1, and I have 8 divided by -2 gives me -4. Please notice that the coefficients next to x have the same value and different signs. Coefficients next to y have the same value and different signs, and basically the constants have also the same values and different signs. So what will happen over here? -2 plus 2 gives me 0, and I have -1 plus 1 gives me 0 equals 4 plus -4 gives me 0. I have 0 equals 0. This is true statement. Anytime you are going to end up with the solution like this, when the left side is equal 0 and right side is equal 0, it means that two lines are going to coincide. Means the lines laying down one on the other. So we also say that these two equations are dependent. The solution set consists all ordered pairs that satisfy either equation. So how am I supposed to write this down? So I'm supposed to say that the solution is the set of all ordered pairs that satisfy either equation. So we have first equation, 2x minus y is equal 4, or set of all ordered pairs x, y that satisfy also second equation. And this is the solution to my problem.